All right, welcome. You're currently in Meticulously Modern Mobile Manipulations, and if that's a bit of a mouthful, you can just say, All right. Today I want to cover some cases for a little bit more advanced mobile application hacking. We'll look at some use cases for Frida and see if we can figure out how we would go about improving our current tooling and improve it in a way that would make it relevant for us from today going forward. And yeah, let's see how that goes. First of all, my name is Leon Jacobs. I'm a security researcher at a company called SensePost back in South Africa. It does not get as hot as this, but we'll leave that aside for now. And I've been hacking stuff for roughly around 10 years now. I have been fortunate enough to play around on large networks at ISPs and maybe a little bit more complicated ones at banks. Now, part of my day job at the moment sometimes requires me to perform mobile application assessments, and to be pretty honest with it, I've hated that pretty much a lot. So I've set out to see what can I do to go and improve the state of mobile application hacking and really just make it a way that it sucks a lot less for me. Now, how we're going to go about that today, we're going to try and see with these three phones that are clearly iOS 13 ready. On a more serious note, we're going to cover a bunch of techniques, but they're primarily targeted at three disciplines from a mobile hacking perspective. The first scenario or discipline would be that of a mobile application hacker that wants to poke around and maybe understand how such an application works. The second discipline would be one that speaks to a malware reverser that maybe needs to understand quickly how a mobile application functions or what it's doing right now. The third scenario is sort of targeted more towards those that are responsible for some development pipeline and might be involved in the CI/CD pipeline to deliver some form of testing. Now, these techniques that you'll see here is probably about 2 years of work that I've been doing on and off, and ultimately the results of it should be shown now. That being said, before we can actually get to that stuff, we probably need to have a bit of a sit down and understand where we're at right now, as if a parent is going to give us a stern warning. The reality of mobile app hacking today is I think we're sort of bearing the fruits of the research of many of those that might have done in this room, where mobile ecosystems are so tightly controlled, they're relatively complex beasts in themselves, that it's quite hard to do a mobile app pen test right now. In fact, there are so many moving parts of this thing that I'm pretty sure you'll groan very loudly when you realize you need to do a mobile app pen test. That being said, things get even a little bit more complicated if we consider the state of jailbreaks. While you may be fortunate enough to have access to commercial products that could give you root access to the latest operating systems, or maybe you have a private jailbreak that you don't want to share, which is fine. For the general populace, with iOS 13 available in beta today, where we don't have a public jailbreak, chances are good that when that becomes the latest and greatest OS and an application is written that makes use of NFC APIs, what are we as mobile app pen testers going to do about when a client asks us, well, you now need to go and look at what that application is doing? Secondly, the result of this testing or these tight ecosystems also means that we can't really understand what's really happening with the apps. If we had to consider scenarios maybe where big data is watching us, and we're not certain that if we are downloading a flashlight application, which I might ask why I want to do that today, is it actually just a flashlight application, or is there different alternative motives to why we have this app in the first place? In fact, how do we get to a point where we can understand how this data that might be used in an application is used against us for monetary purposes or other reasons? This sort of, I believe, forces us to try and reshape how we think about mobile app hacking and look at alternative methods to approach this. One such method could be using a framework or a toolkit called Frida. The reality of Frida is I sometimes find it hard to truly explain what it really does, other than saying it's a toolkit written by Ule Andre, and honestly, I sometimes can't believe why this is actually free. The capabilities of Frida spans far beyond what you might see today, but we'll just focus on the mobile application aspects of this. But maybe before we can understand how that is actually going to help us as app pen testers, let's look at a very quick analogy. In this case, we have a castle or a fortress, and imagine that this castle is the mobile application app that you need to test, or you want to look at how this thing functions. With root access to your device, you can move around in this castle, you can see what's happening inside, you can open any doors, and you're truly free to inspect any aspect of this fortress. However, when you don't have a jailbreak, well, now you're sitting on the outside and it's pretty dark in the inside and you have no idea what's really going on over there. You're not allowed in, you're not allowed to move to a castle next door, and the restrictions applicable to us are quite severe. However, if we had to take and combine that with Frida, we can sort of see it as if this gives us the opportunity to have this light to move inside of that castle and again be in a place where we can see what's going on around us. Now, this man here doesn't have much other than a torch, but the reality is it's a starting point for you to be able to explore and investigate a runtime of what might be happening around you. Now, to actually understand the implementation of this and to leave the metaphor aside, we need to get Frida going on a device. Now, there are two primary operating modes that may be of interest. One would be a server mode, and that's really targeted at if you already have root on your device, then you can run Frida without much restriction. Everything you would see today is applicable in server mode, but we're going to focus specifically on the gadget mode. Now, I must be really honest, this gadget mode excites me a lot, especially the first time when I realized what this is possible to do. And we're going to look at a little bit of that again today. Now, an important part of how would I get gadget mode going? Well, you're going to have to modify a target application. There are some small nuances applicable when considering iOS, but the idea is still the same. For Android, you might take a small little bit of Smalley and you would patch an application to load the shared library, which is the form that the gadget mode would take, and when an application starts up, that gadget is started as well. A similar scenario applies for iOS, in which case we'll modify an application to load the dilib and again get us the instrumentation capabilities that we might need. Now, if we had to move on and consider, well, what might Frida be used for today, and we take the scientific results from 2 Google poems, we could see that if you started typing Frida iOS, the results could give us an idea of what folks might be searching for. SSL pinning bypasses, root bypasses really are pretty common usages for Frida. And make no mistake, this is a super powerful tool for doing that, and leveraging these techniques, I think, is something that we can take a lot further. And maybe if we can try and understand the underlying technique of how these things work, we could maybe move along and see what else we can do. Now, imagine you had a pinning class with a checkpin method. Using Frida, we actually have access to the implementation of that method. So what does that really mean? Well, when it's time for checkpin to run, we now have access to the entry point to that function. We have access to the logic of what that function is actually doing. And finally, and probably more applicable to an SSL pinning bypass, we have access to the return value that that function gives us back. So you now understand how an SSL pinning bypass works. Considering that maybe the implementation simply returns a true or a false, we could use the implementation to modify exactly that. Now, that is a really useful thing to do, and like I've mentioned, something that will probably not go away for a very long time and that we have in our arsenal right now. But we can absolutely do a lot more. In fact, I think we had one scenario where we had to do an assessment. The app does not run on a device that we have a jailbreak for, but part of this assessment meant that we needed to get access to a file inside of that application's container, but without a jailbreak. Now, a little bit of thinking and considering a little bit later, I realized that while when we are doing hooking, we can manipulate existing logic that is within our application, we can actually also go and introduce new logic. And when I'm saying new logic, I'm actually just saying that there is a class available for us to use in the runtime, and we can instantiate a fresh instance of that class. Now, Frida makes this super easy for us to do by simply running using some of the APIs that Frida exposes. The first of all would be the Java use case, in which case we're just instantiating a new instance of Java io.file here. For Objective-C environments, there might be a class called SI files, and in this case, we're simply allocating and initializing that class. Now, when we're just initializing these classes, we now actually have a variable that we can call the methods applicable to that class ourselves. In fact, if we start combining these things, we're in a scenario where we can actually start building some extra tools which might result in us extending functionality that's not necessarily part of that original application that we are testing. Now, in our case, remember the part where we needed to get access to a file inside of a container? It's exactly this thing that happened. In fact, I started writing a bunch of scripts which resulted in a toolkit that I wrote called Objection, which in its infant stages was actually just a file manager using exactly the same building blocks that a developer would have used if they wanted to build a file manager, and add some capability to list files within a containers directory and ultimately download those out again. Now, file manager is an interesting scenario, so let's have a quick look at what that might look like. In this video's case, I hope it's this one, there we go. You should see an existing session for Objection running already, and there was some file interactions that happened. You know, you could cd through to the directories within the container and inspect what the contents of the file system might be. Now, applicable to this demo, one quick little bit of information that you might need to understand is if you're using an iOS app and you had to background the app, iOS will take a screenshot of that application's current state, and this is to make it nice if you're using the app switcher to know what the last states of that app might have been. Using the file manager that we've built, we can go to that directory and see what those files are and quite possibly download them as well. So in this case over here, using a relatively familiar interface, we go to the snapshots directory that contains these files, and if we had to hit the ls here, we'll see the files themselves. Now, like I've mentioned, we could do something like just downloading this file and inspecting what it might be. But what if we started thinking about what else we can extend our app with? In this case, we're actually going to consider adding an HTTP server to the target application, which I should have mentioned is YouTube over here. And this would actually start the HTTP server on my iPad, allowing me to browse to the iPad's IP address and view that same directory listing from a web browser. More importantly, this is not functionality that exists in this application out of the box. We've used instrumentation to augment what we wanted to add to it and build our tooling on from there. All right. Now, as you may have seen, this really opened a lot of possibilities for us. In fact, furiously, we're at a stage where we're building new tools, porting older ones. For example, imagine the old keychain-dumper, which many of us are probably familiar with. From an outside rooted jailbroken perspective, that keychain-dumper really just interfaces with the SQLite database on iOS. But within an application container, if we wanted to build a keychain-dumper, we can actually just port that same logic and have it contained within the container and still be able to understand what's being stored when I'm using this application at runtime. Now, one thing that might be interesting or that could help understand how all of this fits together is the super explanatory picture that would link, and you should see the little line over there, all of these components together. First of all, you would have the JavaScript runtime that Frida exposes for us that we could use to write some scripts. But that won't be the starting point if you wanted to write a new tool. In fact, you would probably target the Objective-C runtime if you wanted to write your keychain-dumper. But to make use of this from a Frida perspective, once we have some valid Objective-C running, we can now port that over to the JavaScript runtime, and that's what the little link should show, and run it from there. The exact same process applies when we're speaking of a Java runtime, or even if you wanted to run some native code. Stringing all of these runtimes together is ultimately what gives us that ability to work with these runtimes and build fresh new tooling. But okay, let's shift gears a little bit and consider application heaps. When we're speaking of an application heap over here, really what I'm saying is we have a class, we've instantiated an instance of that class, and that would live on a heap for a certain amount of time. That instance itself has methods that get called from it, and whatever the reason is of why we have this, it might affect some state of the application. Now, a lot of the research that you'll see over here hinges off an ex-colleague's work that was done, Chris Leroy, that explored the idea of using Java objects that live on the heap to possibly identify some forms of malware and then try and understand how that works. But for us, and what I've hoped to try to take this further, is to say, well, what else can we do with this stuff? If we're considering application heaps, maybe the first thing that we need to understand is what type of classes that are on the heap could be interesting. A list, as you might see there, could be things that handle cryptography in some way, that might make socket connections out on the internet, maybe handle some states for the target application. There might be some configuration set for your app, or if in an Android world, there might be a class loader that loads some classes from the outside. If we understand maybe what classes might be interesting, maybe if we zone in very quickly of what we might want to do with such a class, it could look something like this. Methods could exist on a class that could get and set properties. A class itself has properties which has some values. And understanding what those values are could actually tell us what the state of that class is right now. But more importantly, if we are calling methods on that class, we might actually be changing the state of that class that is as it is right now as the application is running. Now, a lot of this stuff might seem a little complicated, but from a Frida perspective, we really have two APIs that start exposing this stuff to us. We could simply use the java.choose runtime, the java.choose API, and that would actually just enumerate us instances of a target class that we might want to interact with. Similarly, in the Objective-C world, again, the choose API would do the same thing. But that's now a lot of talk. Let's consider what this might look like and a way we could use this. What you should see over here is, once the video loads, is there's a terminal on the left-hand side and where we're going to interact using Objection. And on the right-hand side, there's a video that's looping from the TikTok application. Now, this application itself, I spent a little bit of time reversing it just to understand what it looks like. And I've identified one class of interest that seems to be controlling the current video that's playing right now. Now, using that choose API wrapped over here from an objections perspective, we can actually enumerate live instances of that class, like I've mentioned, that we might want to interact with right now. The output of the command I just ran gives us 3 instances that we might want to work with. We could copy one of those, which is a pointer to that class, and now start interrogating it to understand more about it. One way we might want to do that is to actually tell it, show me the instance variables that we have for this specific class that lives at that pointer. The answer that we get back is actually a bunch of information which includes all of the properties for that class, including some values that it could easily read. You'll see many of these are actually handles to more classes, so what we can try and do now is to try cast those to UTF-8 strings, which should result in much more information about what this class is doing, what its current state might be, and in other words, actually what the current video might be that is playing. Now, understanding what's inside of the class, we might choose a different route and maybe see which methods do we have exposed to us by purely interrogating that actual class itself. By doing a heap print methods command, we should get a list of methods that we can run on this class instance that's on the heap right now, and maybe see that there's a play command and a pause command, and these are the type of things that we might use to interact with the video that's currently playing at the back. Now, like I've mentioned, we might want to change the state of this thing. So to do such a thing, we could actually just go and execute that method that we have found for this instance, and if we hit the pause method over here, we should see the video pause using the interaction that we've just done. Naturally, to continue, you could just go and call the play method once again. Now, in this case, we've had 2 method calls that didn't accept any arguments. They're really simple calls. They don't do a lot really interesting. So let's consider other methods that might be a little bit more complicated. One such method that you would find in that list would be set content URL string, and you would see it accepts 1 argument. Now, from a Frida perspective, you can write a separate script, or from Objection perspective, you could get a new command that we'll show in a second that will actually give you a JavaScript variable to the address that that pointer points to. So if we do the evaluate method here, it will tell you that the PTR variable is actually just the variable that binds to that address on the heap, and we can now work with it. Now in this case, I actually want to change this video to a little bit more educational one. So I have found a URL for such a video on YouTube, and I now want to change TikTok without interacting with it to play that video as we have it. So we've identified set content URL string. So we're going to call that method on that PTR variable, again, which is just a pointer to the object, and give it the URL argument that we wanted to load. The next thing that you would find, if you were to reverse this app a bit, there would be a prepare to play method, and all this really does is just downloads it in the background and gets it ready to display in the foreground. Now, next thing we might want to do with this little script is to actually set or give ourselves a bit of a visual indicator that that was successful, right? So the only thing we'll do then is just log that we're done, and wrapping all of that up, run the script itself. When the script runs, you see in the background that the app itself is now just gone dark. So the next thing we might want to do is just to ask it to actually play that. So like we've already been doing, we'll just call that play method on top of it, and we'll enjoy some recreational content that may inspire you to do this yourself. Awesome. Okay, but I think the point to take from here is using simply one address. I'm also sure this is the most of us have seen of the video before you just close it. But an important takeaway from this is you've enumerated an instance of an object, we've manipulated it by pausing and playing, and we've actually changed its state by setting a variable and making sure that that loads up, giving us a nice visual indicator that something has changed. Now all of that was iOS specific stuff, so let's consider Android. Well, exactly like you've seen over here is actually applicable to Android as well, and from an Objection perspective the interaction is pretty much the same. Again, in the underneath it uses the same APIs that we've been using for iOS, so there's really not a lot different over here. However, if we had to look at one example for Android very quickly, we could take the YouTube app and ask it, show me the instances of the Dex class loader that are live right now. What's quite nice about the Java runtime, it has a toString method on many classes, so we could actually very quickly see what that method's properties might be, or at least some of the properties that the class might have. Okay, now we've noticed that there's a the.apk, I promise I didn't name it that, and now that we know where it might live, we have a path, we could probably just go about and use the file manager that we already have and download that for further analysis later. Again, this doesn't require you to have root, you just needed to modify the app to get the gadget going, and you could quickly get to some content that you might not have known initially from static analysis. Now while on that topic, what about applications that we're unsure of what they're actually doing? Or ones that you're relatively certain is probably malware? Well, obviously you could perform some static analysis, reverse the app, see what is going on underneath the hood, and get a good idea of what it might be doing. However, at the same time, that could be a pretty tedious task, and depending on how the app is built, it might not be a very easy thing to do. In fact, it's not really a secret to know that apps might actually try and hide their true intent, well, malware apps for that. Interesting techniques like using a packer or some really heavy obfuscation might make it difficult for you to understand from a static analysis perspective what an application is truly up to. And if you don't have a lot of time and you maybe want to collect some IOCs very quickly, again, a static analysis approach might be a little bit tricky. One method a lot of apps might use to try and make this a little bit difficult is to actually use reflection. By using reflection, they could programmatically make calls to methods, and depending on what the source of that logic might be, the method calls themselves are not immediately known. However, from a runtime perspective, we could actually have this exact same method hooked, and as they're using reflection to invoke calls, we could use that to understand what the calls themselves are. Now, one such piece of malware was something that we had a look at that would load a jar file actually out of a bitmap, and once the jar file is loaded, use reflection to call methods that's on top of that. We have a sample hook here that I want to show you very quickly that does exactly that, hooking the reflection methods to understand what the app is doing. Now, one thing I would need to do is apologize for the speed of this. I've actually slowed it down quite a bit. But we're running a malware application here in an Android emulator. There's no way I'm installing that stuff on an actual phone. Some of it is really, really dodgy. But by hooking the invoke method for reflection, we can actually see all of the calls and possibly some of the arguments that are being used to make these interactions that the malware is supposed to be doing. Now, like I've said, this is slowed down quite a bit. You don't have to worry about actually following on all of that. But towards the end, we should start seeing some socket classes making network connections out to the internet. So we can quickly deduce at this point that there's probably something strange going on here, or at the very least, there's some network activity that we might want to have a look at. Now, once we've inspected maybe some of the network activity, maybe we want to try and understand how this application actually came to make this logic happen in the first place. Well, one such thing, like I've mentioned, the DEX class loader could be used to load arbitrary code from outside of what you may have expected it to come from. And we can see over here that using reflection, the class loader was loaded, and it actually tried to load that jar file that you can see in the path over there. More interestingly though, once that jar was loaded, it actually deletes it off disk using a delete call later, and making it a little bit harder for you possibly to catch that and actually uncovering what this malware might be up to in the first place. All right, so I hope that sort of gives you an idea of how that might work. But what about existing tools? What about tooling that developers are using to augment their development experience or making their lives a lot easier? I truly believe as security professionals we're probably missing out by not leveraging the exact same tooling that they might be using as well. In fact, some of that stuff I've seen, I can't believe that is free and you can actually use it yourself as well. Anyways, one way, if we had to use instrumentation, is we could actually side load this existing tooling into an application that doesn't have it and make use of exactly the same features a developer would do. We can leverage an API from Frida if it came in the form of a shared library using simply module.load and pointing it to a path on disk within the application's container to a shared library that might have the debug tooling that you're interested and use that. Now, shared libraries are not the only form in which these things can come. In fact, you could also have a Java tool, obviously for Android, and you can sideload that, much like malware probably would do it, but allowing you to leverage the same features that they might have. I want to look at two examples relatively quickly today, of which one would be Flex from Flipboard, which targets iOS, and another would be the Stetho project from Facebook. Both of these tools are tools that developers can use that absolutely augments their development experience and probably more so the debugging experience that they might, or scenarios that they might need to debug. The first would be Flex, and I'll load this. And you should see over here, just pause that on the left-hand side we have the terminal with some interactions from Objection, and on the right-hand side I have the YouTube app that's just connected with QuickTime to the Mac. There is a plugins flag that you're probably seeing for the first time now. That was a community contributed feature that allowed us to just side load Frida scripts quickly within Objection. However, the most important thing really to understand from that is it's just Frida script at the bottom and there's nothing really different about it. Anyways, if we decided that we wanted to load this Flex plugin, we could run a command like plugin flex load, and all this will do is using that file manager that Objection originally had to upload the shared library into a directory, finally call module.load, which will result in this little debug bar popping up in the YouTube application. Now, I can tell you that the YouTube app doesn't have Flex by default, but we've now just sideloaded Flex and made it possible for us to use it just like a developer would do to understand what this application might be up to and make use of any of the features Flex has for us. One thing, it has a really cool network inspector, so I would highly encourage you to have a look at that as well. All right. Now, from an Android perspective, like I've mentioned, we have Stetho as an example. And in this case, for Stetho specifically, sorry, I just need to get this proper demo. Let's take a little bit of a longer route around this and understand what's happening. We have a shell on the left-hand side, an Android app that's streaming to my phone, to my laptop, and a Chrome inspector at the bottom. I've launched the Reddit app, and I'm just quickly going to interact with it as if I am normally using this application. I'll go to my favorite subreddit, read a little bit of news, and probably get bored of that pretty quickly. With an Objection, though, at this point I might be interested in which activities are available within the runtime right now. Now, at runtime, you can query Android's packet manager, and that could give us a list of activities that is targetable right now. If I had to go through the list of activities that I've enumerated, one such activity might catch your eye called the data logging activity. Well, data logging seems interesting, so let's go and build a fresh intent, again using Java to run via JavaScript to launch the actual intent, but wraps up in an easy command like you'd see here, which should result in that activity actually launching on the Android app and letting us use it. In this case over here though, you should see quite a lot of tracking related logs, and if you go into the detail of some of this stuff, it's a little bit hair-raising really to see why they need to know what the current theme is as part of your browsing experience. But okay, we can keep that in mind on the side. Now, I might decide that at this stage, maybe I want to use Stetho's features to browse data on the device itself. Much like the Flex scenario, we can just load Stetho up using a plugin, and that should result in a class loader being used to actually instantiate the classes in a jar, and finally call the initialization method that it has. Once that's done, the way Stetho works, it has a inspector that you can use at the bottom. And if you inspect that, it's just a normal Chrome inspector that actually gives you access to the files within that container, so preferences files in this case, or SQLite databases that you might have access to as well. Over here, we might notice the PeriDB, and in that case, see events relatively similar to those that we saw in the data logging activity itself. Now, what's possible here is you can run raw SQL queries on that data, and what you should keep in mind is if you have an application that actually has some state stored within a SQLite database, changing the data in that database might actually affect the state of the application that you're targeting. Maybe there's a key in there that you could update to something else, or, you know, let your imagination go pretty wild. All right. Now, what about integration? If we had when I had this thoughts about, you know, how could I make it that we can integrate the things, it seems like a very difficult thing. But when I had a bit of a thought about it, I realized like a lot of the building blocks on how to do this actually already existed. Now, when I do speak of integration, you know, from my perspective, it's really just HTTP requests into something that would give me some results back. If we had to consider an architecture of what that might have looked like, we already have the Frida gadget involved somewhere in an application. We already have a bunch of Python tooling written around it. So really the only thing that was necessary was to expose an HTTP server from which an HTTP client would be able to connect to, serializing messages using JSON. In fact, this resulted in really just 3 lines of code, you can check me on that, to get it to work. So that was like quite surprising and easy to get going. However, the result of that would mean we could now make a curl request and using runtime instrumentation go and figure out, for example, the binary protections that an iOS app has. This is just one of the many scripts that exist in Objection, and make some decisions based on that if we require them to be enabled or not, or maybe even question their existence in the first place. Now, just being able to use curl commands might be interesting, but we could probably actually add this to a Jenkins pipeline. So if we had to look at what that might look like, I have a project over here that is configured using Jenkins. There's the configuration of the project is actually quite simple. The first step would be to just build the app that I have, and this app has the gadget embedded. The next step is just some simulator commands to actually get an iOS simulator running, installing the app that just got built. Once that's done, we would start up Objection, which will give us that opportunity to interact with the Frida gadget using HTTP messages. And finally, the actual checks that we want to make sure that certain protections are enabled and that we fail if they don't. Finally, just some cleanup scripts to save space on my limited hard drive. All right. Now we'll probably go into the build phase. And although this is a little bit small to see, the details are not too important. This will now just go through that entire phase of actually building the project, modifying the simulator, and getting to a point where the Objection API is actually listening. And that's what you should see over here in a sec. Once that's up and going, again, this is now an app that's actually running in the simulator. At runtime, we are querying to see what are the binary protections of the final artifact that we've had on the device. This is that binary that's probably going to be the one that's going to get shipped to your end client. Because my project is configured in such a way that has all of these protections enabled, my build completes, and I'm now at a state where I can continue with whatever the next step might be. So I'm hoping that gives you an idea of probably many other use cases where if you're concerned of what the last final stage of your app is, you could use instrumentation in an automated fashion to query that runtime and assert certain features that you might need. All right. So let's quickly recap about what we've just said. We're saying that apps are, at a runtime for many disciplines. It might be interesting for us to query that. This is applicable for hackers. This is applicable for malware reversers, and even those folks that might be responsible for a CI/CD pipeline. Some of these techniques that you've seen today absolutely overlap for some of these disciplines, but the general idea is that it would enable us to improve the actual testing that we're doing, and we're not relying on old tooling that might not be working on a non-jailbroken device. So to summarize all of that, I would love for us to realize that runtime analysis is more than just hooking. It's much more than just SSL pinning bypasses. Although absolutely powerful, we have the ability to build many more tools and extend our arsenal that we have. We don't always need root to run these types of things, which means that if iOS 13, for example, had to drop today, we still can test and we can still do a proper analysis of how these applications might work. Finally, irrespective of what your discipline is, anyone can use this. It's applicable to many folks involved in some form of mobile application pipeline. And as a final stage, we can use this for the greater good to actually understand what our apps are doing. If our data is being shifted off somewhere, we can catch that. And I think it's everyone's responsibility here to actually do that, and I hope this encourages you to do that. Thank you. One final thing that I'd like to mention, the stuff that you've seen here should be available in the release that I would make an objection as soon as I can get to a computer after this. And yeah, awesome.